Welcome to this DataStatPro tutorial on reliability analysis. In this video, you will learn how to evaluate internal consistency, inter-rater agreement, ordinal agreement, and the reliability of continuous measurements. We will demonstrate Cronbachs alpha, Cohen's and Fleiss kappa, Kendall's tau, and Kendall's W, and the intraclass correlation coefficient, with automated coding and publication-ready interpretations. Let's explore the comprehensive reliability analysis capabilities available in DataStatPro. First, visit the DataStatPro website by entering datastatpro.com in your preferred web browser. Once the landing page has loaded, open the application and sign in using your registered credentials. After signing in, you can access the reliability analysis module in two ways. From the top navigation bar, select Advanced, followed by Reliability Analysis. Alternatively, use the left sidebar and select Reliability Analysis under the Advanced Analysis options. Both routes will open the same analysis module. This comprehensive module supports several methods for assessing reliability and agreement. You can evaluate the internal consistency of a scale using Cronbachs alpha. You can assess agreement between two raters using Cohen's kappa, or agreement among more than two raters using Fleiss kappa. For ordinal variables, you can calculate Kendall's tau and Kendall's W. You can also evaluate the reliability of continuous measurements across different raters or time points using the intraclass correlation coefficient, commonly abbreviated as ICC. Let us begin with internal consistency reliability. This method is commonly used to determine whether the items included in a multi-item scale consistently measure the same underlying construct. These scales frequently contain Likert-type questions. A distinctive feature of DataStatPro is its ability to analyze Likert responses stored either as numerical scores or as text categories, thereby reducing the need for manual data preparation. For this demonstration, we have prepared a dedicated reliability analysis dataset. It has been specifically designed to illustrate the different analytical capabilities available in this module. The dataset includes numerically coded Likert-scale items and text-based Likert responses. This allows us to demonstrate how reliability analysis can be performed without manually converting text responses into numbers. The dataset also contains categorical assessments from multiple raters, ordinal satisfaction and ranking variables, and continuous measurements recorded across raters or time points. Therefore, we can demonstrate all the major reliability and agreement procedures using a single dataset. You can load the dataset by importing it as an Excel file. Select Import Data, locate the reliability analysis file on your device, and then select Import. The dataset previously displayed in Excel is now successfully loaded into the DataStatPro workspace and is ready for analysis. Importing an Excel file is one option. Alternatively, you can use one of the built-in sample datasets available within DataStatPro. A dedicated sample dataset has been created specifically for reliability analysis. Selecting this option loads the same dataset used in this demonstration, allowing you to practice each procedure directly. Now that the data are available, let us begin the analysis. Open Advanced and select Reliability Analysis. This module supports Cronbachs alpha, intraclass correlation, Cohen's kappa, Fleiss kappa, Kendall's tau, Kendall's W, and other related reliability measures. At the top of the module, you can confirm the currently active dataset. In this example, the reliability analysis dataset contains 96 observations. The first step is to select the variables to be analyzed. We will begin by selecting these 5 scale items. These are Likert-type items stored numerically, with response scores ranging from 1 to 5. This represents the first scenario, in which the scale items have already been imported as numerical variables. Since the responses are already coded numerically, no additional coding is required before conducting the analysis. After selecting the 5 items, click Calculate Cronbach as alpha. The calculated alpha coefficient is 0.8979, indicating good internal consistency among the selected items. DataStatPro also generates an APA-style interpretation that can be adapted for inclusion in a research manuscript, thesis, or analytical report. The item-level statistics show how each individual item contributes to the overall reliability of the scale. These results can also help identify items that may weaken or improve internal consistency. The Cronbach as alpha dashboard provides a concise visual summary of the analysis. Based on the calculated coefficient, the selected items demonstrate good internal consistency. Now let us consider the second scenario, in which Likert responses are stored as text categories rather than numerical scores. Data exported from online survey platforms, such as Google Forms, frequently contains responses written as strongly disagree, neutral, agree, and strongly agree. Normally, these responses must be recoded before statistical analysis. In this section of the dataset, the Likert-scale responses are stored in their original text format. Select Likert items 1 through 5 to include them in the reliability analysis. We will first examine the situation in which all selected items follow the same response direction. In other words, none of the questions requires reverse coding. In some questionnaires, positively and negatively worded questions may have opposite scoring directions. For the present example, however, all 5 items follow the same scoring direction. The unified coding option is therefore selected by default. Under the standard 5-point Likert scoring scheme, strongly disagree is coded as 1, disagree as 2, neutral as 3, agree as 4, and strongly agree as 5. DataStatPro automatically recognizes these categories and converts the selected text responses into their corresponding numerical scores in the background. Cronbach as alpha is then calculated using the converted values. Click Calculate to run the analysis. The resulting Cronbach as alpha coefficient and supporting statistics are displayed immediately. As demonstrated, there is no need to manually recode the categorical responses or create additional numerical variables before conducting the analysis. In some scales, however, all the items may not follow the same direction. For example, this dataset includes a negatively worded item that requires reverse coding. After adding this item to the analysis, the coding scheme is no longer uniform across all the selected variables. In this situation, turn off the unified coding option and specify the response scores separately for each variable. For the reverse-coded item, strongly disagree is assigned a score of 5, disagree a score of 4, and neutral remains 3. Agree is assigned a score of 2, while strongly agree is assigned a score of 1. This flexible approach allows you to define the correct scoring direction for every item without permanently modifying or recoding the original dataset. Next, we will examine inter-rater reliability, which evaluates the level of agreement between different raters or observers. In the first example, 2 raters have evaluated the same cases using categorical ratings. Select the variables representing rater A and rater B, and then calculate Cohen's Kappa. Cohen's Kappa measures the agreement between 2 raters while accounting for agreement that could occur by chance. DataStatPro presents the Kappa coefficient, the relevant significance test, and an APA-style interpretation of the findings. When categorical ratings are provided by more than 2 raters, Fleiss Kappa can be used. In this example, select the variables representing raters A, B, and C, and then calculate Fleiss Kappa. The results are displayed together with the necessary statistical details and a concise interpretation of the overall level of agreement among the raters. Notice that each completed analysis is automatically appended to the analysis summary dashboard. This allows you to review and compare all completed reliability analyses in one centralized location. Now let us move to ordinal association and agreement. When two ordinal variables are being compared, Kendall's tau can be used to evaluate the strength and direction of their association. For this example, select the ordinal satisfaction variable and the ordinal loyalty variable. Both variables contain ordered response categories. If both ordinal variables use the same response order, the unified coding option can be retained. For a standard 5-point Likert scale, strongly disagree is coded as 1, disagree as 2, neutral as 3, agree as 4, and strongly agree as 5. Once the coding order has been confirmed, calculate Kendall's tau. Once again, the text-based categories do not need to be manually converted into numerical values. DataStatPro performs the required coding automatically before completing the analysis. In this example, the results indicate a weak ordinal association. The coefficient, significance test, and corresponding interpretation are displayed and added to the analysis summary dashboard. When agreement is being evaluated across more than two ordinal rankings, Kendall's coefficient of concordance, or Kendall W, can be used. For this demonstration, select the available ranking variables. If all rankings use the same ordering system, retain the unified coding option. If the directions differ, define the appropriate ordering separately for each variable. Click Calculate to perform the analysis. The results indicate strong agreement among the selected rankings. The Kendall W coefficient, significance test, and interpretation are displayed and automatically appended to the analysis summary dashboard. The final method demonstrated in this tutorial is the Intraclass correlation coefficient, or ICC. The ICC evaluates the reliability and agreement of continuous measurements obtained from different raters or across different time points. For this example, select Continuous Measurement 1, Continuous Measurement 2, and Continuous Measurement 3. These variables may represent numerical measurements recorded by different raters, repeated measurements performed using different instruments, or measurements collected at different occasions. Click Calculate Intraclass Correlation. The output displays the selected ICC model, the ICC coefficient, and the corresponding measure of agreement. In this example, a two-way agreement model based on single measurements is used, and the results indicate excellent reliability. DataStatPro also provides the associated statistical details and an APA-style interpretation. The ICC findings are also added to the analysis summary dashboard. As demonstrated, DataStatPro provides a comprehensive and flexible environment for evaluating internal consistency, inter-rater agreement, ordinal association and agreement, and the reliability of continuous measurements. Its ability to analyze both numerically coded and text-based responses substantially reduces manual recoding and simplifies the complete reliability analysis workflow. Thank you for watching.